And you can unmute if that's quicker.
Yes, miss, I did do it early.
Okay, that is perfectly fine. You should be, I don't remember that we had put on there that you could only fill it out once. So you should be able to do it again. And if not, we're actually going to write it down on our paper anyway. So you can just turn that into Miss Lee as well. You do have Miss Lee, correct?
Yes.
Okay, awesome. So don't worry about that. We're going to go through it anyway. So if you guys take a look at your notes, which I'll go ahead and throw over here, that's a PDF that I had attached, that all of us attached for today. So if you want to write in this format, that's okay. I like to write things a little bit differently. So that's why I'm just going to do it on my piece of paper. What we are requesting nonetheless is you'll notice that we are going to do 3 examples together, and then it says you try. You're going to do 3 examples on your own, another 3 on your own, and then you have these last 4. Overall, you have 10 questions. You're going to take a picture of your notes, or if you're doing yours separately, your 10 questions on a separate piece of paper, that's okay. Look, I got lots of paper with me, okay? You are going to get a grade for your 10 questions. 6 of them are on, well, technically all 10 of them are on the notes, but you'll also notice that we gave you an exit ticket on Google Forms. That also has the last 4 problems on there, okay? All right, so let's go ahead and begin with our notes. Oh yeah, might want to bring back these. I'm going to throw them over here so that I don't confuse y'all. All right. So a polynomial. Have you guys ever heard that word before, polynomial? Look into the chat. You can unmute if you'd like. Has anyone ever heard the word polynomial? No. Okay. All right. That's not bad. Don't worry. All right. So we're going to define polynomial. If you break down that word, have you guys seen poly before? Have you guys seen poly before? And I'll zoom in for my blind little bats. I'm sorry. Poly. I know that you guys have definite. Who's poly? No, P-O-L, 1-L-Y. Yeah, kind of like in polygon, right? What does it mean whenever we move to poly? Do you guys know what that prefix means? Yeah. What do you got? This one isn't a trick question. If you're thinking, no, I don't want to say it, it's not that easy. It is. It is that easy. Poly, usually you guys associate that word, that prefix with many. Have you guys heard that before? Poly means many.
Yes.
Yes. Okay. All right. What do you think nomial means? Oh, that one. What do you think nomial means? What do you think nomial means? Yeah, it kind of sounds like numbers, right? I'm going to abbreviate because I ran out of space, my bad. So polynomial means many numbers, if you break it down into the prefix and such. Now, of course, I want to give you guys a better definition than that. So polynomial, we're going to write that down as an expression made up of, oops, why did I put it? There we go. Made up of variables constants and coefficients. Then it says that involves, man, this one is a little bit longer, sorry. I'm just going to put the symbols so that we can shorten this up. Addition, a giant plus sign for y'all. There we go. Subtraction. Multiplication. And I think that would be it. Non-negative integers. Oh. And exponents. And then I believe it asks for a couple of examples below that. Yes? So, example. Give me a number, your favorite number. Somebody unmute and give me your favorite number.
99.
78.
And then I didn't see who had said the second number. What was that? Oh, I see a 7. What was that second number?
78.
78. Okay. Is that a positive or a negative 78?
Negative 78.
Ooh. Wild child. Keep going. I need some more numbers. Either unmute or type it into the chat. I got
466.
that. 166 is what you said?
Yeah.
Oh, okay. Was that positive or negative?
Positive.
166. I'm going to add a 5 here. And yeah, sure, why not? So here we have a polynomial expression. So you'll notice I have variables. Remember variables? Those are your letters. All right. I have constants. Ooh, you know what? Dang, I am so going to use my highlighters for this. So hello, I'm Miss Gomez and I'm addicted to color. All right. So we have variables right here. We also have constantes. Now, in case you don't remember what constants are numbers that are not attached to variables. They have no letters attached to it. Tan solo, okay? We have coeficientes. Now, coefficients are numbers in front of variables, like 99 or negative 78. And we also said that we have exponents. Exponents are also numbers, but they're superscripts. They are small numbers that are raised above everything, kind of like Superman. That's the way I remember that. And then lastly, we also had our operations, like subtraction and addition here. The multiplication is technically there because it's here between the 99 and the x. They're being multiplied. All right. So here is a nice example of a polynomial expression. Let's go ahead and continue. It says when adding, where did I put my black pen? Oh, everything else is black. I couldn't see any. All right. When adding or subtracting, polynomials, we can only add or subtract and this is the super important one, so I'm going to grab out my giant red marker. Like terms. All right, that's what goes in those two blanks there. can only add or subtract like terms. And so we're going to go ahead and give this a shot. So we have examples 1, 2, and 3. What I'm going to do is I'm going to split my paper in half so that I'm going to have my side here that we do together, and then you guys are going to have your side over here. ¿Tan bueno? Sure. Okay, thanks. I appreciate your feedback. So we have example 1. And that has parentheses 3x plus 3 plus parentheses 2x plus 16. Now, I have a quick question here. What the function do those parentheses mean? What do those parentheses mean? I mean, why are they even there? What do you think
You
the
have to
purpose?
do them first or something, like PEMDAS or something.
Yes, yes. So what part of PEMDAS do you think those parentheses are used for? Like what purpose does it serve having those parentheses there?
The order of operation.
Okay, so what do you think about the order of operations and those parentheses?
Multiplying?
Ooh, parentheses could mean multiplying. Do you think it means multiplying in this case here?
No.
So then what else could it mean? You're absolutely correct, though. Parentheses usually mean multiplication, but they also have another purpose. Ooh. Now, do that first, adding. Ooh, you guys are getting so close. So I agree with, I hope I don't mispronounce, Teresa? Did I mispronounce? Tell me if I did. I'm so sorry. I think I did because you're taking a while to reply. I'm so sorry. Oh, can you correct me? I don't mind being corrected. Or you don't have access to unmute. We'll work on it. I won't put you on the spot. Oh, okay, that's all right. Well, I'll talk with you later so I can make sure that I don't function up again. So, Miss Chavez had said that the parentheses are telling us to add because that's in between them. Now, what these parentheses are doing is they are acting as grouping symbols. All right. So what it's doing here is I'm saying this is one group over here, the 3x plus 3. And then over here is another group, the 2x plus 16. All right. And I'm taking this group and I'm adding it to this group. Well, goodness, that seems so simple. And actually, let me take a look at this. Let's see if YouTube will work with me, because sometimes it doesn't, because it's just mean. I kind of like the way that this guy had set up. I know I had shown it to one of my classes. I can't remember if it was you guys or if it was my geometry class. Let's see. Oh, yeah, here we go, here we go. Okay. Going to play. Let's see here. I know I need to present it a certain way. There we go. Okay, so we're going to watch a little bit of this. I'm going to fast forward because he talks about all this stuff about math that you really probably don't even care about. Here we go. All right.
Here's how to add and subtract fractions. I start with the apples plus apples lesson. First I ask, what's one apple?
Let me let that load up real quick while I pick up the volume. All right.
Plus one apple. And kids will often say 2, which is partially correct. have them include the words as well, since math is a language. So it's not just 2, it's 2 apples. Next is 3 pencils plus 2 pencils. You all know that pencils plus pencils give you pencils. So everyone, how many pencils? 5 pencils is right. And the key is you included the words. I tried this lesson with my 5-year-old niece once. After she added pencils and pencils, I asked her, what's 4 billion plus 1 billion? And my aunt overheard this and she scolded me and said, are you crazy? She's in kindergarten. How's she supposed to know 4 billion plus 1 billion? Undaunted, my niece finishes counting, looks up and says, 5 billion? And I said, that's right, it is 5 billion. My aunt just shook her head and laughed because she did not expect that from a 5-year-old. But all you have to do is take a language approach and math becomes intuitive and easy to understand. Then I asked her a question that kindergarteners are definitely not supposed to know. What's 1/3 plus 1/3? And immediately she answered 2/3. So if you're wondering, how could she possibly know that when she doesn't know about numerators and denominators yet? You see, she wasn't thinking about numerators and denominators. She thought of the problem this way. And she used 1 apple plus 1 apple as her analogy to understand 1/3 plus 1/3. So if even a kindergartner can add fractions, you better believe that every 5th grader can do it as well. Just for fun, I asked her a high school algebra question. What's 7x squared plus 2x squared? And this little 5-year-old girl correctly answered 9x squared.
Now, I wanted to pause it here because this is what I'd like to do. Just like he said, this is an algebra problem that he gave to a 5-year-old. And it kind of makes more sense whenever we line it up. Now, what he had done is he already had addressed, he didn't give the 5-year-old multiple terms. He gave her 2 like terms. And she lined them up and was able to say 7x squared plus 2x squared is obviously 9x squared. Just like 1 apple plus 1 apple is 2 apples, she's not going to change her fruit and say 1 apple plus 1 apple equals 2 oranges. That just makes no sense. So what I'd like to do is take a look here. We're going to grab some colors. Oh man, I really hope you have some colors. So I'm going to grab pink and blue. Why not? All right. So I'm going to use the 2 different colors to first identify my like terms. So please tell me. I'm going to use pink and I'm going to circle. Now, in case you don't have different colors, see, I knew it. Don't you worry, boo. What I like to do is use different shapes. So I'm going to make a pink circle and a blue box. So don't worry. I got you, boo. All right. So I would like to circle in pink some like terms. What do you want me to circle? And right now, any answer is correct. It's the second one that might be incorrect. So what would you guys like me to circle to begin this finding the like terms process? You can either unmute or type it in. Unmuting is quicker. Just tell me any of these terms and I'm going to circle it. There is no wrong answer right now.
Like on the screen that you're sharing?
Yes. So from the 3x plus 3 and the 2x plus 16, what would you like me to circle? Just give me any one of those terms and I'm going to circle it.
3x plus 3.
Oh. So 3x plus 3 is an entire expression. Now a term is actually, good thing we brought this up. The term is going to be part of the expression that is separated by the plus or the minus sign. So like this polynomial right here has 3 terms because the minus sign separates the 9x to the 7th power from the 78x to the 5th power from the positive 166. So the 3x plus 3 is one entire expression. I just want one part of it. Oh, I am so sorry. Thank you for reminding me. Ooh, 2x. I'll go ahead and circle 2x. And thank you, Matthew. I'm so sorry. All right. So Abigail says, let's circle 2x. Okay, like I said, as long as you give me one term, no wrong answer. Now, now is the difficult part. I need to find a like term. Now, if you didn't do yesterday's assignment over like terms, you might be a little lost, okay? So I'll just, in case, remind you guys that like terms is a term that has the same variable raised to the same power. Ooh, Michaela is on fire. She already says, I know 2x's like term is 3x. I'm going to put another pink circle around it. Are there any other like terms that I should circle? Remember, if you don't have colors, you can just circle. No, I agree with Michaela. So I'm going to put down my pink pen. I'm going to pick up my blue pen, and I'm going to put a blue box around another like term. What is another like? Oh, Brianna. So Brianna is recognizing my constants of what kind of 3 is that actually? Is that a positive or a negative 3? So I'm going to include the plus sign in my box. And what kind of, oh, okay, you confirm for me that my 16 is also positive. All right. Now, one thing to note, I believe we had stated it with our, oh, wait, you know what? No, we should probably add it on here, that our polynomials, the exponents should be in, oh, you know what? Let me make that a little bit bigger because I like to be very visual. This is also why I like pencil, because you don't have to use whiteout. Whiteout can look kind of ugly. Do you guys know what the word descending means?
Goes down.
It makes sense, right? There we go. So descending exponential order. So our polynomial should be in descending exponential order. I'm going to change that to a comma. And then I'm going to write in red because it's a little important. Constants are always last. Okay. Sorry if you guys had to squeeze it in there like I did too. So because I'm recognizing that my constant is always at the very end, and Brianna had recognized that we have two constants of 16 and 3, I'm going to put them in order here, kind of the way that we saw in the video. So I'm going to say 3, and then I'm going to put a plus sign and a 16. And I'm going to bring over my two variables here, and we're going to combine them, which means to add, and say 3x plus 2x. All right. So remember, this is our whole apple situation. 1 apple plus 1 apple equals 2 apples. So 3x plus 2x equals
5x.
Oh, thank you. You even had to say it like the audience did too. Thank you, Matthew. I appreciate that. So 5x. Now that was only one set of like terms. I had another set of like terms that I need to combine, giving me what comes after the 5x. Ooh, be very careful, Brianna. What kind of 19?
Positive 19.
Positive 19. Whoop. Thank you very much, Desiree. So plus 19. Boo, that's my answer. And I'm just going to go ahead and box it. Okay, not too bad. Now, I took this one really slow, you know, so that you could see all the steps. So our second one shouldn't be as drawn out. So let's go ahead and write. I'm going to skip a space and put number 2. So I'll have more space on the back anyway. Number 2, again, has a grouping symbol, and it says 12x. Ooh, minus 3xy. Oh, man. Then it closes that group and says plus a group of 4x plus 5xy. Oh, and you know what? I forgot to draw that line across here. Okay, there we go. So these are the ones that we're doing together, and these are going to be the ones that you do on your own. All right, so I'll go ahead and use my pink and my blue again. Tell me, what do you guys want me to circle in pink? Remember, there's no wrong answer at this point. Just make sure it's one term. Ooh, the 12x. Okay. All right. So again, if you don't have color, just go ahead and draw a circle around it. Is there anything else that I should circle because it is a like term? It has the
4x.
same.
4x.
Ooh, my bad, my bad. Man, you guys are on top of this. Okay. So I'm going to go ahead and line them up here. Okay. So let's see. Ooh. Gosh, there's just so much more that I didn't write here. So you know what? I'm going to put it right here. So not only should my exponents be from greatest to least, but I also need to be in must also be in alphabetical order. All right. So x versus xy. X is going to come first. So I'm going to write that 12x plus 4x. Okay, what do I box in blue? Negative 3xy. Thank you so much for being very specific, Abigail. Anything else I should box in blue? Ooh, positive xy. Okay, so I'm going to write negative 3xy. So you see how we pretty much just rewrote our group down here and then rewrote my second group below it. All right. What do you guys think my final answer should be? You can either unmute or type it in.
16x.
16x, you are correct. ¿Qué más? Ooh, this one might be a little tricky, huh? So I'm going to cover the variables because remember, it's just apples and apples. But it says negative 3 apples plus 5 apples. Yeah. So this would be our commutative property of addition. So it says that negative 3 plus 5 is the same as saying 5 minus 3. So because we're using addition, we can kind of flip our stuff around. So I definitely agree. It should be a positive, thank you, Ricardo, 2xy as our final answer. Okay, let's move on to example number 3. All right, and that one says, I have to make sure to write it kind of skinny. 3x plus 4y, and I think you guys might even be going ahead of me, and that's okay, plus 7z. Now, you might want to be careful with your z's because they can look like 2's. And that's my first group, and my second group is 3x minus 2y plus, now here it says z, but I want to be a little bit more specific. How many z's are right there? Ooh,
1.
Ooh, nothing's getting past you guys, not today. So I'm going to go with my giant pencil because I can't find my regular pencil. And I'm going to put a little dotted 1 in front of it. All right. Tell me what to circle, boo. Ooh, 3x. Which one? Both. Love it. Anything else I should circle? You guys ready to move on to a blue box? What do I put? Ooh, 4y and 2y. Can you be a little bit more specific? Negative 2y. And what kind of 4y is that?
Positive.
Positive. There we go. Ooh, looks like I should bring out my green triangle. What do I put a triangle around? Be specific.
Positive 7z and positive 1z.
Oh, yes. Thank you so much. Now, because I'm following alphabetical order, which comes first? Circle.
The 3x's.
The x is the circles. So I'm going to line up 3x plus 3x. There we go. What comes after that? Box or triangle? My y's, thank you very much, Ricardo, which I have in my box a positive 4y and a negative 2y. And lastly, obviously my z's, right? So that's a positive 7z plus 1z. Okay. Now, let's just focus on the pink ones for now. And I'll scooch that a little. There we go. 3x plus 3x. 6x. Good job. 4y minus 2y. What kind of 2y? Positive, okay. Plus 2y. And lastly, 7z plus 1z. Be specific.
Positive 8z.
Ooh, yes, positive 8z. All right. Now, you guys have 3 examples to do on your own, and that is example number 4, which was, I'm not going to waste my time writing them, so I'm just going to write them right here because you guys have that written on your paper, and I kind of want to move on to the back side. So I'm going to flip this over. Man, that marker still bled through. You know what? I'm just not even going to bother with that right now. There we go. See, that's why I had extra paper with me. I knew that would happen. All right. So let's go ahead and continue with example 7. All right. So example 7 says 7x plus 3 minus the group of 2x plus 1. Ooh. This one is strange. That's why I wanted to jump ahead and not waste too much time. So Why is this one a little different?
Because you're not adding your two groups.
I'm not adding my two groups. In this case, that's subtraction. So, gosh, I can't remember who said it at the very beginning. I believe it was Matthew, told me that parentheses mean multiplication. Now, along with multiplication and grouping symbols, whenever we see parentheses, we should think of another word that we were discussing on yesterday's assignment. Other than combining like terms, what else were we discussing? For those of you who watched yesterday's assignment, what was the other word? Gosh, nobody remembers the other word?
No.
Thank you for your honesty. I'm going to help you out here. Nothing yet?
Descend? No. Distance?
Distribute.
Distribute. Yeah, that was the other word from yesterday's assignment. Distribute. Now, usually when you have distribute, you'll have something like parentheses. And in this case, we have a minus sign on the outside. We need to distribute, aka multiply, that minus sign to all of the terms inside of the parentheses. So I'm going to highlight, and if you don't have colors and make it really dark, that's why I'm using a marker. I'm going to highlight that negative symbol, and I need to distribute it to the first term. What is the first term that it's going to be distributed to? What is the first term? Ah.
2x.
Actually, it's going to be the 2x because I'm talking about inside of the parentheses after it. So I can see the confusion. So whenever I distribute the negative to a positive 2x, what does it become now?
Negative 2x.
It does become negative 2x. So I'm going to bring that down. Negative 2x. Am I done distributing to everything inside those parentheses?
Nah.
Nah. What else, Ian?
How are you gonna make the positive one a negative one?
You are absolutely correct. I still need to distribute to that positive 1, and it does become a negative 1. Now, at this point, now that I am no longer subtracting two polynomials, I'm just going to bring everything down, and I don't need to have the grouping symbol. So just like before, what should I circle? Now that I distributed that negative, what do I circle?
You got your 7x and your negative 2x.
Ooh, Ian, what a good answer. 7x and negative 2x. Should I box anything in blue?
Your positive 3 and
Positive
your negative 1.
Oh, yes. You guys are so on point. Now, which goes first, my pink circles or my blue boxes?
Circles.
Pink circles.
The circles, yes, because that one has a variable. Remember, constants, those are in the numbers without the variables. They go at the end. So 7x plus 3x, and then positive 3 minus 1. What's my final answer? Keep going.
4.
Almost. No es de suma. 2. Yes, we're subtracting. Love it. Now, we are out of time and there are still 2 problems that I didn't go over. So at the end of my geometry, I'll record those last 2 and send it to Miss Lee, and I'll also post it in my classroom. You guys are still responsible for, numbers 4, 5, and 6, which you guys can see over here on the PDF that I sent y'all. You need to do 4, 5, 6, 10, 11, 12. I am going to do those last 2 for y'all. And then your exit ticket, you can either just do it here, which Matthew, like you said, you had already done on the Google Classroom. Don't worry. They're right here. It's the same ones. The only difference is that you don't have a multiple choice to choose from. Okay. But I think that you have a much better idea now. Any last minute questions?
Okay, I just wanted to finish off these last 2, 8 and 9 problems with y'all. So just like number 7, whenever we have this negative, we have 2 different polynomials that we are subtracting. Well, we definitely want to distribute that subtraction symbol into all of the terms inside of the parentheses. Now, I do notice that I have 2 terms that's separated by the plus sign. So this negative is going to be distributed to both of them, just like last time. Now that gives me negative 4x, and then negative times a positive is another negative 3xy. And at this point, I'm just going to bring everything down. X minus 5x y. Okay, so I'm going to go ahead and take out my purple pen, my pink pen and my blue pen. And here I am going to again circle in pink my 2x. And another like term would be negative 4x. All right, and then of course I would put my blue box with negative 5xy and negative 3xy. Now remember, alphabetical order matters. This is just a solo x, and y comes after, so that would come second. So let's order this up. And minus 4x, and then negative 5xy minus 3xy. So let's focus on just the pink. 2x minus 4x. Well, that gives me negative 2x. Okay. Now, I know that you guys have a little difficulty with integers here. So in this case here, I have negative 5 minus 3. Now, what happens is whenever you are subtracting from a negative number, it's becoming more negative, a bigger negative number. Some people even say it's kind of as if you just add the negatives together. So negative 5 and negative 3 becomes negative 8xy. Okay. There we go. There's that answer. And lastly, we have our first group. This one is a 1, 2, 3 term polynomial, and that is 2x plus 9y plus 7z subtract 4x minus 4y plus z. Hey, we dealt with this before. That z, how many z's are actually there? Just like last time, I'm going to put an invisible implied 1. All right, don't forget that's 1z. Okay, so let's go ahead and distribute that negative because I don't want to have to forget about that later. Let's just get it out of the way right now. So negative, now just like I said, this time I have a minus sign here and a plus sign here. I actually have 1, 2, 3 terms. So this negative is going to go here to 4x, to negative 4y, and also this positive 1z. Oh, goodness. So, negative times positive 4, that's going to become a negative 4x. Uh-oh, negative times a negative. Yeah, you guys know that's a positive 4y. And negative times a positive, that's just going to be negative 1z. Okay, now I'm going to bring everything else down. 2x plus 9y plus 7z. And now we get to circle, box, and triangle everything. Okay, so I'm going to start with my first term. Why not? 2x. Now, I do have another like term, which is negative 4x. I'm going to box my next term, positive 9y. Oh, I have another positive 4y right here. Now my triangle, my last term here has a z. Now that's a positive 7z and a negative 1z. So let's go ahead and rewrite everything in alphabetical order, x, y, z. I'm going to start with my pink circles. That would be 2x minus 4x, okay, plus 9y, and right below it, plus 4y, okay, and then plus 7z minus 1z, okay. Now, I know I didn't have to write the 1 there, but it kind of helps later. Okay, so 2 minus 4. Now, if you're having difficulty, please know that you can always draw a number line. So I went ahead and drew out this number line here, and I'm obviously going to start at 2. Now, if I'm starting here at 2, and I am subtracting means to go to the left on your number line. So I'm just going to count, subtract 1, 2, 3, and 4. Sweetie, if you got to write out a number line, don't worry. At least you'll always get the right answer. So that's going to be negative 2x. Don't forget the variable. Remember, apples and apples. Okay, so this is a lot easier because that's just 9 plus 4. That would be a positive 13y. And here I have 7 minus 1. All right, 7z minus 1z equals positive 6z. There you go. Final answer time. Okay, and like I had stated, you guys have to finish numbers 10, 11, 12, and then you also have your exit ticket questions, the last 4, number 13, 14, 15, 16. Please be very careful whenever you're writing this down because 15 and 16 look very similar, except the first term is different, and also this one you are adding, this one you are subtracting. Okay, please be very careful. You also have numbers 4, 5, and 6 to do on your own. So you have 4, 5, 6, that's 3 problems. And then 10, 11, 12, that's 6 problems. And then 13, 14, 15, 16, that's 10 problems to do on your own. Okay, so now if you did your notes together with your work like I did, then what you're going to do is take your cell phone and you're going to, once you're done, make sure that you guys can see that, you're going to angle and then take a nice picture. All right. So once you have both the front And then you're going to take a picture, of course, with your work on there, okay? And then you're going to attach it to today's assignment, all right? Should you have any questions,